Hi, hello, I'm Kumar from Nature of Physics and Arts. Today topic is young modules applications and last class is young modules formulas are completed. Now applications, that is series combination and parallel combination of the wires. First one is series combinations. For this, considering two wires of length L1 and L2, these are connected end to end with one end is to the rigid support and another end is connected to the load. That's why downward direction F is the force acting, that is the gravitational force. Okay, and first wire young modules is Y1 and second wire young modules is Y2 respectively. First one elongation is E1 and second wire elongation is E2. Due to the force acting downward direction, there is a elongation in the wire 1 is E1 and wire 2 is E2. Now we have to find the total elongation. Total elongation E, which is equal to E1 plus E2. See, young modules formula I am going to use here. Young modules, which is applicable within the elastic limit, it is defined as the ratio of longitudinal stress to the longitudinal strain. Denoted letter is Y, and young modules only possible in solids, not possible in the liquids and gases. That is, only solids can applicable for the young modules, and next liquids and gases do not possess the young modules. See, first young modules formula, Y is equal to FL divided by EA. So young modules is defined as a ratio of longitudinal stress F by A to the longitudinal strain E by L. After rearranging, we got this equation. Now elongation equation, E is equal to FL divided by YA. See, now the values are replacing in the above equation step by step. So E1, E2 values along with E also. So F, here one thing remember, force is constant, F is equal to constant, and two wires have the same area. Then F L1 plus L2 divided by Y effective into area is equal to E1 is F L1 by Y1 into A. Next E2 value is F L2 divided by Y2 into A. So in this equation, LHS side and RHS side, F by L is common and constant. That is L1 plus L2 divided by Y effective, which is equal to L1 by Y1 plus L2 by Y2. So F by A common and cancel. Then the resultant equation is this. In this equation, if two wires have the same length, that is L1 which is equal to L2 which is equal to L, then the resultant equation L plus L is 2L divided by Y effective, which is equal to 1 divided by Y1 plus 1 divided by Y2. L is common and cancel. We got this equation. Rearranging this equation, that is Y effective which is equal to 2Y1 Y2 divided by Y1 plus Y2. Okay, so this is the first equation if the lengths are equal, and this is the second equation. Just a second. Yes, this is the series combination of the wires. That is two wires connected series combination to a rigid support end to end with load. So in which force and area is remains constant. Which are variables here? Elongation and length and young modules of the different wires. That's why continuation here, elongation, total elongation, which is equal to E1 plus E2. Then E1 value, E2 value we are finding from the young modules. So young modules Y is equal to FL by EA. So E is equal what? FL by YA. Then the values are replacing in the above equation. So we got L1 plus L2 divided by Y effective, which is equal to L1 by Y1 plus L2 by Y2. And if length are equal, then we got Y effective, which is equal to 2Y1 Y2 divided by Y1 plus Y2. So we can write Y series, which is equal to Y1 plus Y2 divided by Y1 plus Y2. Okay, so then next parallel combination we will discuss. Just a second, I will clean the board and come back. And continuation, now parallel combination. For this also considering two wires of same length and young modules are different, Y1 and Y2. And area also different. One is area A1, another one is area A2. So length is equal to same and even elongation also same, because of bottom of the two wires are connected to the one conductor. That midpoint is suspended to a load with mass M. So the F force which is acting downward direction, that is equally distributed on the first wire and on the second wire. So the net force is F, which is equal to F1 plus F2. Try to understand here. See, just roughly I took here F1 and F2. F1 on the first conductor, F2 on the second conductor. But F1 plus F2 is F. So we have to take actually only F, but for understanding purpose I took F1 and F2 individually on the first one and second wire. Okay, so F1 and F2 I have to replace from the Young module formula. So Young module formula, Y is equal to FL by EA. From this equation, force which is equal to YAA divided by L. So F net force which is equal to, here we have to replace these values in the above equation. Then Y effective, E remains same, area is A1 plus A2, okay, divided by length is same. This F value is replaced in this equation, but we have to take in the resultant Y effective. This is area is total area of the two wires, which is equal to F1 value is Y1 EA1 by L, and the F2 value is Y2 EA2 by L. Because of elongation and length both are same for the both wires in the parallel combination. Young modules, first one is Y1, second one is Y2, area is A1 and area is A2 respectively. So now here E by L is common and cancel both sides. So Y effective, which is into A1 plus A2, which is equal to Y1 A1 plus Y2 A2. So E by L is common and cancel both LHS side and RHS side. Okay, so now Y effective, which is equal to Y1 A1 plus Y2 A2 divided by A1 plus A2. So if areas are same, A1 is equal to A2 is equal to A, so both wires are parallel combination, then area is same. Optionally considering if then the resultant equation is y parallel combination, which is equal to y1 plus y2 divided by 2. Because of this is a common, y1 plus y2 divided by a plus a is 2a. So numerator a, denominator a is get cancelled. So then one example we can discuss based on the parallel combination. Just a second, I will come back. See, in parallel combination, wire length same, elongation same, but force is distributed by the load. That's why F load, which is equal to F1 plus F2. F1 and F2 value based on the values replacing from Young module equation. Here we got force is equal to YEA by L, and E by L is constant, replacing we got Y effective, which is equal Y1 A1 plus Y2 A2 divided by A1 plus A2. If both areas are same for the wires, then we can take A1 is equal to A2 is equal to A, then the resultant equation is Y1 plus Y2 divided by 2. One example, just a minute, I will come back with cleaning board. Now one of the example, considering a wire of length L. Now this wire, one end is connecting to the rigid support and other end is free end. Now for free end, M1 mass is connected. That's why tension is created in the string is length of the wire is T1, tension. Okay, so downward direction, what is takes place here, F1 is takes place, weight of the body, and in this situation the length is L1 of the wire. Because of there is a elongation, that's why total length is taken as L1 and elongation is E1. What is the E1 value? E1, which is equal to L1 minus L. That represent the elongation of the wire due to the tension T1 and F1 is acting force downward direction. Both are equal in magnitude, opposite in direction. And next, second situation, here load is increases, nothing but mass is increasing. That's why the elongation length is L2 and the corresponding load is taken as F2 and tension in the string is T2, elongation is here E2. So here E2, which is equal to L2 minus L, clearly given the diagram. See, this is the L and this is the elongation. Elongation is equal total length minus L, so L1 minus L. Here elongation, which is equal to L2 minus L, clearly I gave you. From the Young modules we have to find the relation. So Young modules Y, which is equal to FL by EA. Rearranging this equation, so here E, which is equal to TL divided by Y into A. Okay, just E and Y is exchange, that is cross multiplication. Then we got here F is equal to, I wrote in the form of tension. Okay, so the resultant equation here, E directly proportional to the T when L, Young modules and area are constants. So from this equation, elongation is directly proportional to the tension. So two wires, two experiments we are doing. So E1 divided by E2, which is equal to T1 divided by T2 from this relation. So E1 value is L1 minus L divided by E2 value L2 minus L divided L1 minus L divided by L2 minus L for the E1 and E2 respectively. which is equal to tension is T1 divided by T2. Cross multiplication, T2L1 T2L, which is equal to T1L2 T1L. I want to find length, initial length. For this, rearranging this equation, so this is like this. So T1L minus T2L, which is equal to T1L2, and this T2L1 from LHS side to RHS side minus T2L1. So here L is common, so L, which is equal to T1L2 T2L1 divided by T1 minus T2, or we can write L, which is equal to T2L1 minus T1L2 divided by T2 minus T1. Okay, anyhow, both same equations only, just minus common in numerator and denominator, rearranging this equation. Okay, please like and subscribe my channel. And next topic is, that is elongation of the rod due to its own weight. Thank you.